Hello, today we'll be explaining our building damage survey of the basement of the Biotechnology Center for our chemical analysis of the environment and construction materials class, group 403. For this particular activity, we were allowed to examine the engineering building at Tecnológico de Monterrey with a specific emphasis on the basement level. This area features a rectangular main hall delineating the boundary between the central courtyard and the classrooms.
Information about the building. The name of this building is the Biotechnology Center that is located in Tech Campus Querétaro and directed by Armando Violain and designed by Estudio de Arquitectura y Ciudad. It was officially inaugurated on October 17, 2019, and it won a prize that was Firenze Entre Muros Award on 2019 in the category of Best Public Architecture Building. The area of this extraordinary building is 6,200 square meters of laboratories and interactive centers.
And here we have a simple floor plan. The layout of the basement floor of the biotechnology building represents a facility divided into several functional areas. At its center is an open courtyard surrounded by a main corridor that provides access to various rooms, such as laboratories and storage rooms, etc. There are two main staircases and two elevators.
Now, the internal walls. Here we can see some photos of the area and wall, where we found some damage. We mainly observed three characteristic damage on the walls, which were the first one, humidity. It could be because the shortness of breath, the water rising to the slab, due to water leak. The second one were cracks. It could be because the low resistance and the poor quality of the concrete. And the third one, the chip wall. It honestly was the last damage, but it's also important to mention that it could be because the poor concrete placement and the lack of maintenance. Finally, here we can see the sketch of the four internal walls, where we can locate with more detail the damage that I mentioned before.
In the external walls, the most common damage found were superficial cracks or microfissures. These cracks are usually less concerning from a structural point of view, but they may indicate minor issues primarily related to the surface finish and not to the integrity of the wall itself. Some of the most common causes of this type of cracks include poor paint application, low quality paint, or primarily moisture. Since the building is exposed to humidity and temperature changes, the contraction or expansion of materials can cause these microfissures.
Now, moving on to the columns of the basement floor, some observed defects were cracks, surface deterioration, and moisture and staining on some columns in this floor. For cracks, there are some visible cracks near the center and corners of certain columns, with even sometimes a bit of material chipped away. This may indicate structural stress, possibly caused by external forces or internal expansion of the concrete due to moisture. In surface deterioration, the surface of some concrete columns appears rough and uneven, which could be due to wear and tear over time, exposure to elements, or poor initial curing of concrete. In moisture and staining, there are potential signs of moisture absorption in some columns as well, especially on the ones in the exterior areas of the basement floor. And these signs of moisture absorption, such as discoloration in certain areas, are also shown in these columns. This might suggest water infiltration or humidity, which can weaken the structural integrity over time. Like I said before, some possible causes of these little defects to some of the columns could be moisture infiltration, like water may have penetrated the concrete, especially if it hasn't been sealed properly. And over time, this leads to cracks, and it can even lead to corrosion of the internal steel reinforcement inside of the columns. Another cause could be thermal expansion, which is like changes in temperature, which can cause the concrete to expand and contract, which could lead to cracking. And another reason could just simply be poor quality concrete or workmanship. In continuation, this image demonstrates the specification of the columns. There are 3 different types of columns found in the structure. A standard column, which is in purple, that measures 40 by 70 centimeters from a lateral point of view. Next, corner columns, which are in pink, measure 40 by 40 centimeters. Lastly, corner columns, specifically near staircases, measure 45 by 40 centimeters. Another column to mention is one that is connected to a wall, which is colored in green on the image, which is located in the stairs. But since there are only 2 columns and neither had many imperfections, it's not very relevant. On the left, you can see the areas marked with oxide stains, humidity stains, cracks in pillars, and cracks in between the pillar and the column. Well, in the wall, and the cracks between the wall and the pillar. There are 12 total exterior pillars and 20 interior pillars. Among them, the most common issue was humidity. Now, moving on to the floor, some possible causes can be thermal expansion and contraction, which happens in concrete and ceramic materials. And since the flooring in the basement area was made of concrete, ceramic material, and rubber, those were the 3 main floors. Concrete and ceramic materials both expand and contract due to temperature changes, which could have been a possible cause. When the material expands and contracts rapidly, it can lead to cracking. Over time, stress builds up in the material, resulting in these cracks. Another cause could be shrinkage cracks in concrete. Concrete shrinkage occurs as the material dries and hardens. This is especially common if the concrete was mixed with too much water or if it dried too quickly. The drying process causes the material to contract and creates surface tension, leading to cracking. Another possible cause could be heavy loads or impact. For excessive weight or dropping heavy objects on the floor can also create cracks in both concrete and ceramic tiles. In continuation, the flooring of the basement section comes in mainly 3 different types as well: a ceramic tile, a concrete flooring, and rubber material floors in laboratories to prevent accidents. Ceramic tile flooring is found in the hallways, meanwhile the other 2 are indoors. In ceramic tiles, cracks are the most common issue observed. A few are located between the tiles. The concrete flooring had the most imperfections out of all the floor types, such as stains and cracks due to weariness over time. Also, since the concrete flooring is used in areas where they have heavy loads on the floor and used for storage, it may cause a lot of pressure on the concrete, causing it to crack over time. Lastly, the rubber material floors found in laboratories and classrooms had the least amount of imperfections. No concerning cracks were noted.
In the staircase number 1, several damages can be observed on its interior, including peeling paint and a slight crack in the right wall at the bottom. Additionally, a significant presence of efflorescence affects more than the half of the staircase perimeter, as it can be seen in the isometric drawing. These damages can also lead to long-term risks, such as structural deterioration due to moisture and aesthetic problems that impact the appearance of the space. In staircase number 2, there are even more signs of peeling paint in areas similar to those of the first staircase, particularly around the door and on the lower left side. The fluorescence is notable, covering almost 2/3 of the staircase perimeter. However, no cracks are observed, considering what we can see in the drawing and images. The damages in this staircase can also lead to long-term risks such as structural deterioration and aesthetic issues.
The ceiling of the hallways was built of concrete. During the investigation, a lot of damage was found, mostly caused by being in a humid environment. We distinguish 11 different types. Efflorescence is the damage that is most frequently found in the ceiling of the hallway. It is formed when the construction is in a humid environment, causing the salts to travel through the porous material until they reach the surface and crystallize, leaving a white powdery residue. Cracks are another of the most frequent problems along the ceiling and can have different causes, such as thermal expansions, contact with sulfates, poor casting, corrosion of metals inside concrete beams, honeycombs, not adequate protection from premature drying, and concrete surrounded by strong winds. Another damage found were humidity stains. Then, honeycombs, which are holes that can be caused by a bad placement of the concrete or even come from a bad preparation of the mix. In some of these holes, we detected that they had already been fixed with the help of patches. However, they didn't work and they also fell. Oxidation and corrosion can be seen in most pipes for drinking water and compressed air, and at a minor level in the gas pipe. It is also seen, to a lesser extent, in concrete, probably caused by the rods that are in the beams. This problem also happens due to humidity and contact with acids from the environment and can cause serious accidents. And, to a lesser extent, we have porosity, which is usually caused by poor preparation of the mix. If it is not beaten with the rod well enough, then it doesn't compact well, leaving spaces or pores in the concrete. The fungus is produced by the humidity of the environment. In addition, at the time of pouring, garbage remains were left that also affected the resistance of the concrete, probably causing cracks and the concrete to fall. Also, we found chipping due to the environment to which the construction is exposed, such as garbage remains, corrosion, or humidity. The laminations are thin surfaces that separate from the base paving stone due to the presence of water and bleeding air trapped beneath the surface. And finally, cold joints occur when the joint between two components has no adhesion because they were placed at different times. Here on the plan, you can see the damages and its locations in great detail. Our proposals to try to solve all these problems are: use epoxy injection for narrow cracks. This will seal the crack and restore the structural integrity. Meanwhile, for wider cracks, apply a concrete patch using a repair mortar that matches the original material. Apply a waterproof sealant to the surface to prevent future moisture infiltration. Make sure any visible moisture problems are addressed by ensuring proper drainage around the structure. If corrosion of rebar is detected, the corroded steel should be treated or replaced. A corrosion inhibitor can be applied and concrete can be repaired with appropriate corrosion-resistant materials. For rusty pipes, replace them with new, more durable ones, especially the gas pipe. Apply a protective coating such as cementitious waterproofing or silicone sealants to enhance the durability of the concrete and protect against further weathering. Implement regular inspections and maintenance to catch issues early, such as resealing the concrete periodically and addressing any new cracks as soon as they appear. With all this, the aesthetics of the building could be improved, while preventing the problems from continuing to spread like a chain and causing others that turn out to be more serious in the future.
To conclude, we found this project quite useful to know how to do the analysis of a building. In this case, we think that even though we focus only on doing a basic analysis, we were able to learn to identify damage, both structural and aesthetic. All this thanks to the different visits we made to the basement of the Biotechnology building. First, to familiarize ourselves with the environment and then to identify damage that was visible to the naked eye. Then, we made more visits where we took videos and photos to see more damage and in greater detail. And finally, we made some more visits to enter to the different classrooms and take some measurements. Each of these visits was essential to get to know the building well and reach a conclusion about the damages. In addition, we also discussed with another team that was in charge of reviewing upper levels of the same building, and we found testimonies from a laboratory worker where they comment that water falls from the ceiling of the highest level to the floor of the rooms, and from there it filters into the ceiling of the rooms below and so on. We compare this with another of our visits where witnesses also comment that the building has been like this since it was opened in 2019. All this leads us to conclude that indeed, as we suppose when we saw the damage, the biggest problems of the building are caused by humidity.